Hello students, welcome. This is the second chapter of your distributed computing, that is interprocess communications. IPC or interprocess communication is the ability for separate independent processes to communicate among themselves to collaborate on a task. Okay, to complete a task, separate independent processes are communicating. This is called interprocess communication. See, in this diagram, two processes are there, sender and receiver, process 1 and process 2. Process 1 is sender and process 2 is receiver. Process 1 sends a data to process 2, so it is called interprocess communication. Okay, so here when communication is from one process to single other process, the IPC is said to be unicast, and when communication is from one process to a group of processes, the IPC is called multicast. Unicast and multicast. See, in this diagram, the unicast from one process to single other process, unicast. Multicast is one process to multiple processes, that is P2, P1 to P2, P3 and P4. Okay, so it is like your WhatsApp chat. Personal chat is unicast and group chat is called multicast. Okay, so here an archetypal IPC program interface, there are 4 primitive operations for IPC interface. For communication, there are 4 primitive operations, that is send, receive, connect and disconnect. See, the send operation, this operation issued by a sending process for the transmission of data. So sender process will issue this send operation and it will identify the receiving process and it will specify the data to be transmitted. So the sender process will issue a send operation and it will identify the receiving process and it will specify the data to be transmitted. And one more is receive operation. This operation is issued by a receiving process to accept data from the sending process and it will specify the, it will identify the sender process and specify the memory space for data to be stored, because the receiver process will accept the data from sender. So it should specify the memory space, and if the memory space is not sufficient, it will discard the operation. Okay, so and one more is a connect operation. For connection oriented IPC, there must be a logical connection established between the processes. So here the connect operation is essential. And one more is disconnect operation. Disconnect operation for connection oriented IPC, previously established logical connection to be deallocated. The connection established through the connect operation should be deallocated by the disconnect operation. So the 4 primitive operations are send, receive, connect and disconnect. So here the network service protocols can be implemented using primitive IPC operations. So these primitive IPC operations means send, receive, connect and disconnect. For example, HTTP. The one process, web browser, issues a connect operation to establish a connection to another process, web browser. So for example, the connection between web browser and web server. Web browser issues a request for a page, isn't it? So web browser always issues a request. So web browser is a client and web server is a server. So web server provides the required thing to required data to browser. So here web browser issues a connect operation to establish a connection connection to another process, that is web server, and followed by a send operation to the web server, which transmits data representing a request, because web browser issues a request, isn't it? So even this request operation is done through the send operation. Okay, the request is sent through the send operation. The web server issues send operation. This transmits the requested data. At the end of the communication, each process issues disconnect operation to terminate the connection. So this is a small example of these primitive, how these 4 primitive options are used for IPC between web browser and web server. For example, web browser issues a request to web server, and web server provides the required data, requested data to the web browser. So here the four primitive operations are involved. Web browser issues a connect operation, and then issues a send operation to send the request, and web server issues the send operation which transmits required data to the web browser, and at last, at the end of the communication, each process issues disconnect operation to terminate the connection. So here how the interprocess communication is done in the web browser and web server. See, web server and web browser. See the operations. S1 at web server side, S1 accept the connection, S2 it receives the request, S3 is it sends response to web browser, and S4 is disconnect. And from web browser side, C1 makes connection, C2 sends request, C3 receives response from web server, C4 disconnect. Okay. So now event synchronization. So the IPC, these interprocess communications, execute processes independently without knowing what takes place in the process at the other end. See, for example, in web browser and web server, these processes executed independently. So web server it doesn't know what happens at the web browser side, and web browser may not be knowing what happens in the web server side. Okay. So here what happens is, for example, the browser must not issue send operation until connect operation is complete. The web server must not transmit data until the browser is ready to accept the data. See, for example, the browser must not issue the send operation until connect operation is complete. See, first operation is connect, then send operation. So first connection operation should be complete. After that it can issue the send operation. So the web server, it should not transmit data until the web browser is ready to accept the data. The processes are to be notified after completion of the task, isn't it? For the smooth performance of the processes, these things are needed, because the processes are to be notified after completion of each task. Okay. So the simplest way for an IPC to provide for event synchronization is by using a concept of blocking, which is the suspension of the execution of a process until an operation issued by the process has been completed. So here to avoid such a problem, that means the browser must not issue send operation until the connect operation is complete, or such problems we can avoid by using a concept known as blocking. Blocking means suspension of execution of a process until an operation issued by the process has been complete. See, for example, consider a web browser issues a blocking connect operation which blocks further execution of the process until the connection has been acknowledged. See, the browser issues first it issues connect operation with the web server. So it immediate after issuing the connect operation, it blocks the connect operation. Okay. So after issuing connect operation, it blocks the connect operation. So which it blocks further execution of process until the connection has been acknowledged. So subsequently browser issues a blocking receive which suspends execution of process until the operation is complete. See, the browser issues it blocks connect operation until, because before the connect operation is complete, it should not give the send operation, isn't it? The browser should not give any send operation before the connect operation is complete. So it issues blocking connect operation, and then it issues the blocking receive operation, because before receiving the requested data, it should not issue any other send operation. Okay. So the blocking will be terminated when operation is fulfilled and said to be unblocked. Okay. So when the blocking will be terminated. So after receiving data, for example, here first it will block the connect operation. See, after connection is complete, when after the connection is acknowledged, it will unblock the connect operation. So next it will give blocking receive, the web browser will give blocking receive operation, because until it receives the requested data, it should not give other send operation, isn't it? So and after the block the required thing or the operation is completed, it will unblock the process. Okay, the blocking will be terminated when operation is fulfilled and said to be unblocked. The unblocked process resumes the execution. Okay, so in the event that operation cannot be fulfilled, processes will experience indefinite blocking. Okay, so sometimes the process, it cannot be fulfilled. Okay, the expected process cannot be fulfilled. That means the blocked process will experience indefinite blocking, because unblocking will happen only after the completion of operation, isn't it? So if the process has not been completed, means it will experience an indefinite blocking unless some intervening measures are taken. So these intervening measures will be taken by IPC, that is interprocess communication. So indefinite blocking should be terminated by some intervening measures. So blocking operations are referred to as synchronous operations, and operations may be asynchronous also. So what is this synchronous operation? Where there is a blocking in operations, we call it synchronous operations, and where there is no blocking of operations, it is called asynchronous. So what is the necessity of making operations synchronous? For the smooth operation of smooth performance of operations, there should not be any problem. For that we use the synchronous or blocking operations, and operations may be asynchronous. That means there may not be blocking also. If there is no blocking, it is called asynchronous. If there is blocking, it is called synchronous. Okay.